Alright, so let this be our factoring polynomials marathon. Do as many as we can in 5 minutes. Ready, go. So here we have x squared minus 49 is the same as x minus 7 times x plus 7, right? This is a perfect square. This is a perfect square. We have a negative, so we can use difference of squares. Difference of squares is a squared minus b squared is equal to a plus b times a minus b. Next problem. Look, let's change colors every time just to keep it interesting. 5 minutes worth, and go. N squared minus 36 is the same as saying n squared minus 6 squared. Therefore, using this rule up here, we have n minus 6 times n plus 6. If you're not sure, go back and FOIL it. Let's try this really quick. N times n is n squared. N times 6 is positive 6n. Negative 6 times n is negative 6n. Negative 6 times positive 6 is positive 36. Looking at these two things right here, aren't they perfect opposites? Positive 6n minus 6n is 0. They cross out, leaving us with just n squared minus... look at that. He made a mistake. It should have been minus because a negative times a positive is a negative. Negative 36. Check mark for me. Keep moving. The next one says negative 6. Whoa, hello. Negative 16 plus 49h squared. They're trying to fool me here. I realize I'm going to move my pieces around. I'm going to write 49h squared. The sign in front of the 49 is positive, and it still is. This is negative 16, and it still is. Now I can factor this. I can rewrite this part, right? And rewrite this part right here as 7h squared. Why is that true? Because 7h times 7h is 49h squared, right? That gives me my piece. I can rewrite this piece right here. This piece right here, I can rewrite that as 4 squared. So I'm going to take my pieces and I'm going to make them 7h. You want to do plus or minus first? You want to do plus first, minus first, plus. I'll take the plus first, doesn't matter. 7h plus 4 times 7h minus 4. Check it by FOIL. 7h times 7h we know is 49h squared. 7h times negative 4 is negative 28h. 4 times 7h is positive 28h. They cancel out, and positive 4 times negative 4 is negative 16. Give us a check mark there. All right, we're still good on the clock, it looks like, so we're going to keep going. How about this one? Ooh, this could fool somebody. 4g squared minus 50. I'm going to look at this, going to look at the greatest common factor here. I'm going to factor out a 2. So 2. Oh, look at that. It doesn't work, does it? If I factor out a 2, I get 2g minus 25. But look, this is not a perfect square. And if I leave it this way, this is not a perfect square. Not factorable. Good for me. Almost got me. Okay, let's try another one. How about this one? Ooh, look at this one. This is one similar, but I think we might be able to do something with this one. 8d squared minus 18. Going to do the same thing here. Going to look for the greatest common factor and see if that helps us. Greatest common factor is 2, isn't it? 2 times 9. 9 is a perfect square. D squared. 2 times negative 9. How am I checking to see if this works? 2 times 9 is... didn't. Wow, I almost did that, didn't I? Factor out 2. 4. Wow, that could have got really embarrassing. Okay, factor this. And this factors out to what? This factors out to 2 times, right? 4d squared. 4d squared is the same as 2d squared, because 4 is a perfect square, right? So bring this in. 2d times 2d is 4d squared. So we get 2d minus 3 and 2d plus 3. Yes? Okay. I think we did a number of problems. This is the only way you can do this. And here, I really do. I see I made, I started to make a mistake here, but same as you take a look at it and you start to realize, you know what, this didn't work. And when you realize that, it's okay. So just stop. Here, and I started to factor this out. I got in a big hurry, learned my lesson, right? But the good news is I went back and checked. As I went back and checked my math, I found my own mistake, and that's crucial because any mistake that you catch on your own, nobody gets to take any points away from you for making those mistakes. So good work. Practice.